Hey guys, welcome back to the DIY Water channel. Today we are going to be making a heat distillation system. A heat distillation system, as the name suggests, is a distillation system that uses heat sources such as gas, stoves or charcoal to distill dirty water and turn it into clean water for us to be able to drink. Let's find out how it's done. Now for the materials. So there are not very many things that you need for this system to work. The first thing is a pressure cooker. So you don't need a very special one. One like this would work just fine. So this pressure cooker is quite small, but we really don't need anything special. A pressure cooker that works is more than enough of any size. Next we need a pipe. This sort of pipe is more than enough. It should be long enough so that it can stretch around your chest easily. That's how I measured mine, like this, easily. This pipe is going to be good. And one more thing to keep in mind is that it has to be thick enough so that if there's any heat passing through it, then it's not going to melt. Also, the diameter of the pipe should be just enough so that it can fit on top of this pressure cooker, like this. You want this to happen because this is when our distillation process is going to work. So you're going to be needing this. And so that it can fit snugly on top of any size of a pipe like that, you would want to choose plastic. Of course, plastic is not the best option when looking at pipes that you want to use with heat. But of course, this plastic pipe or with heavy duty plastic pipe is going to work very well. And finally, this is optional, but a container. I have an aluminium container, but you really don't need an aluminium container. You could use any container you want. It just has to be there so that it can collect water. So wide mounted is better. Now for where to get these materials. So where to get these materials from? So the pressure cooker is very easy. You can get this in your kitchen. Almost all houses have this pressure cooker, and so it's not going to be very difficult to find. The container, I did not precise any sort of container, so any one that is wide enough like this is more than enough like this. The pipe, this one is a bit more challenging because of its specifications, but the best place to get this would be as a plumber. Plumbers deal with pipes like this and they use it inside the waterworks at homes and stuff. So you can find this pipe at a plumber. You will just have to ask them and tell them about the specifications and you can get this. And the price for this is not very much. I got this one, which is about 1 meter long. This is not very expensive. You will get it for about 1,000 sefa. 1 meter, 1,000 sefa. And of course, the thicker you wanted it, the more the price is. But the 8mm thickness is what I have over here, and that's more than enough. Now for the procedure. So the procedure is really quite simple. All you need to do is connect a few things and we have our system. So the first thing to do is to remove the cap, the top of this pressure cooker like this. And this one we can just keep it on the side because we don't need it right now. And you can see that we have this part exposed. Then you want to take your pipe and you want to push it inside so that it fits snugly into the system. So you would want to use a little bit of force because you want it to fit properly. Otherwise you're going to have a problem. So like this is good. And then to test if it actually works, you can blow into this and see if it comes out on the other end. So it does, and so that means it's working. And this is all we need for our system. Now the next thing to do is to fill the dirty water inside this container over here. You would want to fill it up as high as you want because this is not actually going to affect our system in any way. So you can fill up as much dirty water as you want in here. then you would want to close it. Of course, you don't need to seal this, but it's your choice. You could seal this system like this, and we're ready. To do a small test, you could just blow it again and see what happens. So none of the air actually enters and it all comes back out, and so that's a good sign, meaning that it snugly fits. The next step is to take this whole thing and put it on top of a gas. Once you put it on top of a gas, you want to let it to boil for 5 to 10 minutes so that it's actually boiling properly. And then you want to keep a container under this pipe, because once the distillation process starts, the steam is going to start to accumulate at the top and it's going to escape from this pipe. And as it's escaping, you're going to see smoke coming out of here as well as here. And so that smoke is going to turn into water as it drips down. And when that water comes through this pipe, it's going to fall into this container, and we are going to have a clean water. Because distilled water, of course, is pure H2O. You would want to be careful while using this system. You would want adult supervision, because of course dealing with a heat source is dangerous, and if you're a child, you would want an adult to help you. Now for the modifications. So as you can see, this system, it's quite simplistic and there's not much you need to change inside it. However, there is one modification that you could make to this system, and that is to add a wet cloth to the outside of the pipe. This forces the water vapor to condense back into clean water that we can drink at a faster speed. Of course, there is going to be an amount of wastage when doing this system without this modification. There is going to be steam and water vapor coming out of this pipe that we actually want to come out as clean drinkable water. And to reduce the amount of water which comes out as water vapor instead of clean drinkable water, we can use this modification. This modification is mostly needed when you want to get more gain in a less amount of time. Now it's time for us to test out this system to see if it actually works. So what I have here are 6 samples of water, which are borewell water, house wastewater, atmospherically condensed water, factory municipal water, seawater, and rainwater. So I'm going to be using these 6 samples of water, and I'm going to be using 1 glass of them, and I'm going to be carrying out the distillation process with them, and then I am going to evaluate whether the system actually works or not. So I'm going to be distilling 1 of these samples on camera and then doing the remaining off camera to save time. So the one I've chosen to distill on camera is going to be borewell water, just because it looks dirty. So we don't need any of these anymore, so we can dispose of them. So now we're back and we have only 1 of these samples. So now we just have to pour this in over here, 1 glass as I had said. So we're going to fill this all the way up, because that's how much water we need. 1 glass, very good. There we go. You can see that this is 1 glass of water. And now we're going to be pouring it into this system. So it's going to be very simple, very simplistic. Just have to pour it in and then connect the pipe. So just to be safe, I'm just going to do it like this. All the water goes inside and none is wasted. So you can see all of the water is in. Now I'm going to close this pressure cooker like this. Take out the cap and then connect the pipe. That's all we have to do. Now let's go and distill this water. Hi guys, we're in the kitchen right now. As you can see that this is it's boiling. I put the water inside and it's boiling right now. Now we have to wait until it starts to distill. It takes some time, of course, and so when it starts distilling, I'm going to show. Now guys, as you can see, the water is starting to drop. So I'm going to put it inside here, and you can see the water is going to start to drop. Like already a bit of water is started collecting over here. As you can see, a lot actually fell, and it's actually quite hot. Now you can see it's making those sounds, which means it's distilling now. Just 2 more minutes and then you're going to see it start to come out. Yes, there's one more thing. You have to push down on this like this, and you will see it starts to form. And then if you keep it like this, you're going to see it starts coming out. It's a bit of a lengthy process, so you're going to want to wait. Now you can see the steam coming out. So what you're going to want to do is like this, and then the water is going to start forming eventually, and then you're going to have the drinking water that you're going to be able to drink. Of course, this water is going to be very hot, so you're going to want to be very careful. The water is hot, but of course it's going to start distilling, and in no time you're going to have clean water to drink. So as you can see, a lot, and it's bubbling because it's really hot. But now, of course, you can see you have the water. Now, before we go and distill the remaining samples of water, let us first discuss the advantages and disadvantages of this system. So the first advantage is that it is fast, consistent, and reliable. It is fast because in less than 2 minutes, it starts distilling your dirty water. It is also consistent because on any given day, the system is going to work to its level best. And it is reliable because if you have a lasting gas connection, this system is going to work perfectly. This system also gives you pure water, pure H2O that is. You are going to have no minerals, no parasites, no germs. Some people say that pure distilled water is bad for your health because you are only getting the H2O and none of the minerals that come with it. But this is in fact wrong. You are getting your minerals from the food that you eat, and you do not need the water to give you those minerals. Also, this system kills all parasites and bacteria. This is very good because you do not want any parasites and bacteria inside your water. This system is in a way boiling the water, which in fact kills parasites and bacteria, and that is why there are no parasites and bacteria found inside distilled water. This system also softens hard water. Hard water, by definition, is water that contains a lot of minerals. Distillation, of course, removes all contaminants, even if they are good things, from water. And that is why all the minerals from the water that make the water hard are going to be removed, and this water is going to become softened. Also, this system does not get affected by the quality of the water source. You can take the cleanest looking water that has only germs inside, or you can take the dirtiest water which has oil and other contaminants inside, and the distillation system is going to work the same. Because this system renders pure H2O, and under any circumstance, this water is good for any situation that you are in. Of course, there are many disadvantages as well. First of all, this system is quite expensive. To be able to run the gas to distill the water, you are going to be needing to pay a lot. This is in fact the most expensive DIY potable water system you can do, and that is why it is the most efficient as well. Of course, this is not eco-friendly because when you're using gas, you are going to be polluting the environment. You're going to be releasing carbon dioxide. In fact, some people do not even use gas, they use charcoal to make this system work, and that is why this is even worse. Some advice on this system. Distilled water could lack some minerals, so it is recommended to add a pinch of salt to the water that we have finished distilling. Also, transfer the water from container to container if the water seems too flat for your taste. If possible, don't use this method when you are outside because this system, of course, has high gain, but at the same time, it is not eco-friendly. So a better alternative to this system is using the solar water distillation system. But if you have no other choice and you need to distill water and drink it right then, this is your best choice and your best bet for clean water. Now, I am going to be evaluating the samples of water that I have gotten out of the distillation. So I have left these samples only for 10 minutes to distill, and that is why you can see that the gain is quite minimal. If I had left it longer, it would have been more, of course. But I left it for 10 minutes just so that we could get enough of the amount so that we could test out these samples. So what we are going to be doing first is a sight test and then a smell test. Of course, I'm not going to be tasting these samples. Even though I know it is very safe, I'm not going to be tasting them because of safety reasons. So the first sample we have over here, atmospherically condensed water. It looks really clean. I'm sure that you guys can see that the atmospherically condensed water initially itself was really clean, but over here it just looks like pure drinking water. I really can't make out the difference between this and water that I drink. Next we have rainwater. Rainwater too, perfectly clean. I really can't see anything inside, and you can see a significant difference from the initial water to the distilled one. The house wastewater, this is the real shocker. We can see that the distilled water is perfectly clear perfectly clean, nothing wrong with it. And then we look at the initial water and we see it was so dirty. This proves that the system works for anything, and distillation with heat is good for any sort of water. Next, we have the borewell water. This was the first sample I tested out, and the water is perfectly clean, perfectly clear. I would drink this water if I didn't know it was from the borewell water. The initial water, of course, is really dirty, and it's visible to us that there's a really big difference. Next, we have the factory municipal water. So it too is perfectly clean. There is no contaminant inside, and there's a significant difference from the initial version to the distilled one. And finally, the seawater. Seawater, as you can see, it's perfectly clean. Nothing at all. No miniature particles, no nothing. The water is perfectly clean to drink. And the seawater was visually clean, so that's not a very big indicator as to whether the seawater was cleaned. Doing the smell test. So we're going to be taking each sample of water, and then we're going to be telling you how they smell. So atmospherically condensed water. There is no smell. I am actually not getting any smell from this, and I think that's really obvious because distillation takes out any sort of smell or taste from the water. Next is rainwater. Also doesn't have any smell. I'm not surprised. Distilled water is not supposed to have any smell, and I would be surprised if there was a smell. House wastewater also doesn't have any smell. Neither does borewell water. Neither does factory wastewater. And finally, neither does seawater. This is in fact the first distillation process that I have had in which none of the samples smelled funny or looked funny. This is a 100% pass in the initial test. The distillation works perfectly, and I'm happy with the results. Of course, since I'm not a scientist and I cannot conclude this without any evidence, I am going to be sending all these samples over to a lab so that we can find out if heat distillation actually works or does it not. Until next time, see you. Before you go, let's do a small recap on what we have learned today. Today, we have built a heat distillation system. This system distills dirty water and turns it into clean potable water by using energy sources such as a gas. The materials required to make this system are a pressure cooker, a plastic tubing, and finally, a collection container. The collection container and pressure cooker can be found in your kitchen, and the plastic tubing can be found at any plumber. The procedure for this system is quite simplistic. First, remove the whistle off of the pressure cooker and fit the nozzle with a plastic tubing. Then, fill the pressure cooker with dirty water and put it on the gas for 5 to 10 minutes. Make sure to seal the lid properly. After 5 to 10 minutes, collect the distilled water that comes out from the other side of the pipe inside a collection container. Some advice while using this system. Don't forget not to touch the pipe or the collection container or the pressure cooker with naked hands because it will be really hot. Always have adult supervision when using this system if you are a child. Distilled water could lack some minerals, so adding a pinch of salt or transferring the water from container to container could soften the water further. The advantages of this system are that it is fast, consistent, and reliable. It also gives you pure H2O and it softens hard water. This system also does not get affected by the quality of the water source, which means you can use any type of water and you are going to get pure H2O from it. However, there are some disadvantages as well. This system is one of the most expensive DIY potable water systems out there. In conclusion, this system has a very good water gain capacity. However, it is one of the most non-eco-friendly systems that you can use to get pure clean water.